inversion of configuration and retention of configuration, these terms you must be studying when you are dealing with the chapter called haloalkanes and you have different chemical reactions, whether they follow SN1, SN2, E1, E2. So, you might be having these terms retention or inversion. So, let us check out what are these. So, when we have alkyl halide something like this, so you see halogen X is on the right side, this is at the right side. Now, if I have a reaction where a new group is coming Y is attacking this carbon and X is getting removed. I will take it here, you have methyl, you have H, you have C2H5 and X is here. So, if I have a reaction where I have Y minus and it attacks this carbon and X is removed. So, you get this something like this CH3 and Y comes on the other side where it was present already, right. So, you can see that previous carbon X bond was on the right side and new bond is formed on the left side. So, what has happened is inversion has happened, the inversion has happened. That new bond is on the opposite side where previous bond was on the right and new bond is formed at the left. So, inversion of configuration, we call this as inversion of configuration has happened. That means incoming group has attacked this carbon from the back side, this has gone from the back side. So, backside attack forms inversion product. This happens in SN2 mechanism in alkyl halides. Now, if we had something like this and C2H5 and you had the same molecule and new bond was formed on the same side, that previous bond was broken from the right side and new bond was formed from the right side. That means retention of configuration. Previous bond was also on the right side and new bond is also on the right side. So, this is called as retention of configuration. So, if the position of the bond is opposite of what previous bond was, it is inversion. If the position of the bond, newly formed bond, is same as the previous bond, then it is called retention of configuration. I hope you understood this. Now, over here we have staggered configuration and eclipsed configuration. A staggered configuration explains that the torsional strain or the stability of the arrangement is more, and in eclipsed the stability of arrangement is very less. So, this is a stable conformer, staggered conformation, minimum torsional strain, and this is eclipsed conformer which has maximum torsional strain. So, stability of a staggered conformer is always more than eclipsed conformer. So, I hope you understood, and here we have ethane molecule. So, in a ethane molecule, a staggered conformer has a dihedral angle of 60 degree. That is a very important question that you must always remember. So, that is it for now. Thank you.